Hello, good morning. Welcome to Sunlink University. We'll go ahead and get started here. Our presentation today is improving LCOE from the ground up, how racking solutions impact everything from layout to O&M. Thanks very much for joining us today. I am Patrick Keelan. I'm Director of Product Management here at Sunlink. I help lead the charge in developing our next generation of products and services, at the moment focused largely on trackers. And joining me is Isaac Childress, lead designer for Sunlink and highly experienced in making flexible and efficient mounting solutions. Very lucky to have him here with us today. On the agenda, we'll talk about choosing ground mount systems that make the most of your site, how to influence O&M cost with that decision, some of Sunlink's solutions, why we do what we do, and finally, a short plug for our Sunlink University and Q&A at the end. Before I dive into it, I'd like to set the stage for what we're seeing overall in solar, and I assume many on the line are already familiar with this, but it's worth noting the incredible explosion of interest in solar we're seeing, and hope to be installed over the next decade or so. There's a poll from Green Tech Media explaining that about 515 gigawatts of solar are expected to be installed worldwide in the next 5 years. That's a pretty incredible number, but these figures actually haven't been updated with the latest round of good news for the solar industry. That includes things like in August in the United States, the Clean Power Plan announced by the Obama administration, really encouraging the use of renewables over traditional resources like coal and otherwise. In December, there was, of course, the extension of the investment tax credit, giving everyone certainty about the financial returns of these assets. And then in the Paris Climate Accords, among other things, Prime Minister Modi of India pledged 100 gigawatts of new solar generation by 2022. That's really an indication of just how cost-effective solar has become. India is in great need for additional power generation, and they're in the middle of making a decision whether they're going to go with renewables or they're going to go with coal. And this type of focus on solar is great news for our industry and really the planet as a whole. We see from the graph that fixed tilt makes up 47% of the market, tracking 21%. That's the ground mount. There's also residential and commercial rooftop making up about a quarter. In the United States, we see that tracking is a higher percentage of ground mount than is shown here worldwide. A few years ago, there was about 40% or 30% of ground mounts were trackers. We expect that to grow to about 80% by 2018, 2019. So there are a number of possible solutions in the ground mount realm. We'll be focusing on trackers and fixed tilt. Sunlink's TECHTRACK is in the upper left. Our GEOPRO is in the bottom right. For a long time, we've been debating internally and helping clients make decisions about going fixed tilt or tracker, the benefits of one versus another. I think that, at least in the United States, that debate has largely run its course because there's just an increasing focus on trackers for utility scale installations because of the 20 to 25% energy gain because of trackers. But there are still a huge number of projects that are very, very well suited to ground mount, and in some cases, using a combination of both might be of benefit. So we'll talk about that. At Sunlink, we feel it's very important to match the right product to the site. Talking about the benefits that a tracker gives you, well, that is tied to the irradiance of the site, specifically the direct normal irradiance. That's a synonym for beam radiation, the kind of sunlight that makes a shadow on the ground. In the United States, we have excellent DNI, and that means that trackers can give you a 20 to 25% performance boost. In many other parts of the world, say China or Indonesia, where there's either haze or rain, you don't get nearly that same performance boost. Topography, that's a big one. So if there is rolling terrain or highly sloped terrain, how well is a tracker going to perform there? Even if it performs well, how much of a headache would it be to install? Same with the geotech. If you have a site with highly variable terrain, a tracker might be difficult to put in. There's also the environmental conditions, wind and snow, that we need to check for every product that we put in. A project in the hurricane path in Florida is going to have much different requirements than inland California. Overall, we are seeing a trend towards more challenging sites. As solar expands, people want to put solar in more and more places. Absolutely fantastic. That leads to us seeing every type of site imaginable. And furthermore, developers are no longer willing to spend money to grade the site, make it completely flat, to run geotech on every corner of the site. People need to move fast and make decisions in order to hit their targets. So there are certain things we could do with the racking to help with that. A lot of our focus of our product design is making sure that we can make installers looking like heroes at the end of the job. And as discussed, we're seeing a trend towards trackers, especially here in the United States. Elsewhere, it's a little bit different. Focusing specifically on trackers, we thought this was an interesting graphic to present because we often hear the debate of tracker versus fixed tilt, but rarely have we seen a very clean debate over what type of tracker to use, what type of architecture makes the most sense. We hear about centralized versus distributed trackers, meaning trackers on the right have a linkage between all the rows, and distributed trackers on the left are just a single row actuated by each drive, whereas the ones on the right, they might have a megawatt or more actuated by a single drive. But there's also these different shapes of trackers, and they have different characteristics. And depending on what you're trying to accomplish, one might work pretty well, one might not. One thing to notice here is that the Sunlink tracker, it drives 1.2 megawatts with a single drive. It looks huge in this graphic compared to everything else, but when you start considering a 50 megawatt solar site or even larger, these array blocks start getting quite small. Most solar sites that we do see work quite well with this large array block, and we feel that it has significant advantages in terms of keeping your maintenance costs down, installation costs down. It's a highly cost-effective configuration as well. But if you had a small site or a site with unusual boundaries, moving to a smaller block might provide better utilization of the site, meaning that you could tile more of these trackers into a given boundary. We do have a fair amount of flexibility in being able to trim the rows of the TECHTRACK, which is off to the right, but it's simple geometry says that it's just not going to fit in as well as a very weird site as some of these smaller blocks on the left. Another issue we come up against pretty often is how to manage rolling terrain. Something TECHTRACK is about 5% grade following in either direction. This picture is illustrating how the linkage can flex naturally across some rolling terrain. That's in the east-west direction. Some other trackers, they offer rotating linkages that can have a coupling and provide the flexibility needed to manage that rolling terrain. Of course, a distributed tracker, if there's no linkages at all, that's a huge amount of flexibility. But in the north-south direction, it's a little bit different. Most trackers today do have a long torque tube with a north-south axis. And the only practical way that we see so far is to manage that rolling terrain with a certain amount of flexibility engineered into the system. One notable exception to that would be the ExoSun tracker. They have particularly short tables, one string long. So if there's a fair amount of variability in the terrain in the north-south direction, that is one one to consider. Now, a different direction to go entirely would be to look at a combination of tracker and fixed tilt. There's a number of sites that we see where developers want to use a tracker, but we take a look at the site and, well, it's just not a site that's very well suited to trackers. And it's not just about what the equipment is capable of, it's also about defining the heights of the posts and worrying about backtracking and shading and a whole host of other questions that come up. So one great possibility is to be able to use a combination of tracker and fixed tilt where it makes sense. So on the left we have the topography, and we've mapped out where the TECHTRACK would work nicely. And then we have GEOPRO, which is our fixed tilt solution, filling in for the rest of the site. And so the GEOPRO is able to manage 20% grade, which is well beyond what any tracker available on the market can do. And you notice how it's able to fill in all the corners of the site. In this case, I don't know that you'd actually want to push to have quite that tight of boundaries, but it's a great way to ensure that you're making the most of your site. We often see that developers have certain targets that they want in terms of fitting a certain amount of solar on a given site. We'll also see that the site acquisition cost and the transaction cost to actually finance the deal and all the other things that go into actually getting the solar built, those costs can be fixed. And so being able to put more solar and have more generation on a given site can greatly improve the levelized cost of energy of that installation. It's the same argument that we see being made for the rooftop, where east-west systems are just starting to be noticed because they pack more solar panels on the roof. And the argument for that is that when you consider the fixed costs associated with building a site, having more solar makes more sense. Moving on to talking about O&M, centralized trackers, really the gold standard for low O&M in trackers. They have a long track record, and when we look at the economics of building a tracker, one of the things that a centralized tracker is able to do is use fewer, higher quality components than a distributed tracker would be able to. If we need to spend a couple $1,000s for the automation components of a centralized tracker, and that gets diluted across the 1 megawatt block, that's not a problem. But your budget for a distributed tracker for that same automation equipment would only be a couple $100s. And so we can use really high quality components that are backwards compatible. It's what industry is used to. We can also do things like hydraulic drives. Here's a fun photo that we pulled up of a large turbine shutoff valve that's hydraulically actuated. We like the analogy of hydropower because these are systems that are designed to last 20, 30, 40 years. You'll often go into a hydropower plant and see equipment that's been there for a long time. In Hawaii, there's some plants that have been operating on original equipment for over 100 years, which is really fun to see. And I think there's a lesson there for the solar industry. At present, a lot of the development is happening because of tax incentives, the ITC and the accelerated depreciation. Projects are built, they're flipped to the next owner, held for 5 years to take the tax credits, and then they might be bundled in portfolio and flipped to the next owner. But the reality is these projects are likely going to last a lot longer than the 20-year financing period. They may go on for 30 years or 40 years, and there's some, in some sense we have to wait and see for how long these modern solar assets will last. But we do want to start planning now for that transition where people really take long-term O&M into account. Hydraulics are a great technology in that sense because we know that hydraulic technology is going to be around in a couple decades, and you're going to find someone to service it. So I don't mean to say that distributed trackers are a bad thing. I think distributed trackers offer a tremendous amount of flexibility in certain situations, a certain amount of standardization as well, but it is quite a young technology. And when we think about the operation and maintenance technology, there's a few things that we can do to improve the O&M and ultimately improve the LCOE of that solution. One of the most obvious things is to try and extend the mean time to failure of key components, including the batteries and the motors that are commonly used in distributed trackers. The batteries in particular are a challenge. Take, for example, the lithium-ion battery in your phone. That will last a period of years, but it certainly won't last a period of decades. So knowing that those things are going to need replacement in a period of time that's far less than the useful life of the asset, what do you do about that? Well, one thing that can be done, and we're working on at Sunlink, is advanced project intelligence technologies that make O&M more efficient. So we started building control capabilities for our tracker so that we could understand what it was doing at all times. What's the tilt angle? Is there any kind of fault with the motor? That'd be a rare event, but you want to know if it happens. But as we started doing that, we start seeing all these applications, especially with the entire distributed generation ecosystem. If we take the example of the batteries or a distributed tracker, you could have a maintenance schedule that says, oh, go replace all these components every 10 years. You'd really also want to have a system that allows you to know what percentage of the components need to be replaced or if a certain percentage of the components can stay. Continuing on that theme, this is an illustration of the issue of distributed versus centralized architecture in general. One thing to note about these graphs that these are logarithmic graphs. So on the graph to the left, it looks like the bar is twice as high, meaning that there's twice as many monitoring points per 100 megawatts here, but that's actually about 1 1/3 orders of magnitude, meaning there's actually 40 times more points to monitor, 40 times as many components to replace if that's what needs to happen. Inverters follow a similar pattern. We have microstring and centralized inverters, and by the time you get down to a microinverter, you get into numbers that would be completely impractical to try and sort through a list. Say I have 100 trackers and I need to go down a list of what's happening with each one. Well, I can go down a list of 100, but if I have 3,000 trackers to monitor, there's no way that I'm going to go one by one down a list and understand, well, what's going on. So we need a smarter way for to understand what's happening with each of these bits of the system. Here are some screenshots of the VERTEX technology that we're developing. VERTEX is the name for our project intelligence and control solution. On the left is a quick example of what it would look like to have a portfolio of projects and be able to understand at a very high level, very quickly, how each of those projects are performing. So the size of the rectangles corresponds to the capacity of the project, and the shading of the rectangles indicates how well each of these projects are performing. And we can do a similar thing with individual trackers or string level data or whatever we want to pull into it. So we're really excited about that, and if you're interested about this type of solution, join us for next month's Sunlink University, and my colleague Kate will be talking about that. And with that, I will hand it over to Isaac.
All right, thanks, Patrick. So in the context of the challenges that Patrick brought up, I'll try to talk for a few minutes about how Sunlink's solutions specifically deal with those challenges. First of all, for those of you familiar with Sunlink's tracker system, you may notice that we've changed the name to TECHTRACK, and that change was really made to emphasize the robust mechanical technology combined with this new VERTEX project intelligence. Patrick mentioned the importance of long-term reliability in choosing the right tracker. We certainly designed TECHTRACK with reliability as one of the founding principles. And probably the most identifiable feature of the TECHTRACK is its centralized hydraulic drive, which is pretty unique among the top-tier trackers. As Patrick noted, you can find the drives in a variety of industries like heavy machinery, aviation, and power generation. And as Patrick also noted, they're found in life-critical applications like the valves that he showed earlier that not only protect critical equipment, but can protect lives by preventing flooding. And similarly to the hydraulic drive, our controller is built from well-known technology with industrial-grade components. All the components in the controller are designed to last for the life of the tracker without replacement. But if something does happen that's outside of anyone's control, you can bank on the fact that the components are available and field replaceable. So our use of these robust industrial components is also the foundation for a much more attractive operations and maintenance projection, both for costs and logistics. The parts are standardized and available anywhere in the world, and you can find skilled mechanics and technicians also throughout the world. The parts have really been optimized for decades across these various industries, so that reliability ultimately leads to a long life for the tracker. We also talked earlier about choosing the right technology for the right site. As Patrick's earlier diagram showed really well, the footprint of the centralized TECHTRACK product really prefers to be quite large. But that said, we do have flexibility in fitting into site boundaries. As you can see on the right side here, the site tapers down to a narrower width, and we can adjust the size of the tracker blocks to tile in there nicely. In addition to the focus on reliability, we're constantly improving our designs from the perspective of minimizing the levelized cost of energy. So we're improving components like the torque tube splice, which saves both material and labor. We have increased the tilt range from 45 degrees to 52.5 degrees to really get the most out of that late afternoon sun. And we've been working with module manufacturers to approve really efficient rail designs that are kind of a step change in cost. And then when it comes to certain sites that have more challenging terrain, our fixed tilt GeoPro product can really handle situations that no tracker on the market currently can. One of the features we considered from the start in the design of GeoPro is foundation flexibility. It can be mounted on driven piles, ground screws, helicals, ballast footings. Those ballast footings could be precast or cast in place. If you're driving piles and you encounter a refusal, that foundation can easily be swapped out on the fly with a ballasted footing, which is really an attractive proposition for sites that have significant geotechnical risk. Now, GeoPro also has, as Patrick mentioned, a 20% east-west grade falling capabilities. That's both on constant slope or rolling terrain. And the piles for our system are always installed vertically. That's different than a lot of our competitors who may be able to handle terrain challenges, but they may require components to be swapped out, or sometimes even that the piles are installed perpendicular to the grade. And that may sound like a good idea on paper to make everything fit together, but talk to any installer and they'll tell you that it's a really challenging operation to actually perform. It can also create problems in just providing guidelines that are clear and consistent for locating those piles. You might have more measuring of slopes and angles and back and forth with engineers, and that ultimately leads to delays. So in contrast to that, with the GeoPro system, you simply install the piles vertical where they're shown on the layout, and the system will fit together without having to really worry about anything. We also built in the flexibility to handle the vast majority of modules with the same standard components. If you need to make a last-minute module change, the chances are very good that the same racking design will work. And the standardization also enables us to provide short lead times for this particular product. It can be as low as 2 weeks, depending on the project size and location. On to Power Care. We now offer installation and O&M services for both TECHTRACK and GeoPro projects. Here you can see a list of the services we offer. Of course, we can provide them in any combination depending on your own specific expertise or needs. And whether you take advantage of these services or not, having a racking vendor that has the in-field experience and capability is really key to dealing with the challenges that we've been discussing. If you do take advantage of the services, there's no passing the buck when the unexpected is encountered. There are some other benefits to Sunlink having these services in-house, like the fact that problems that are encountered in the field can really quickly make their way back upstream to the design team, and we can implement solutions to those problems directly into the product. With PowerCare's experience dealing with issues like challenging soil and the terrain, our customers often find that difficult projects can be successful where previously they might have thought they had to just walk away. So beyond installation, PowerCare also offers a wide range of O&M services, as you see here. And in addition to the boots on the ground service, we are also adding the monitoring and control and visualization capabilities of the VERTEX software that Patrick mentioned. So with that, I will hand it back over to Patrick to talk about the next opportunity for Sunlink University.
That's right. If you want to learn more, the next webinar is on April 12th, 11 a.m., titled Filling in the Blanks, How What Your Data Monitoring Isn't Telling You is Threatening Your Financial Returns. That'll be a great one. Register at sunlink.com/webinar. And please also, if you have the opportunity, visit our warehouse in San Leandro. You can check out all the product moving through our facility and also our demo systems, get your hands on what it takes to install these systems and how we make it easy in that regard. And with that, let's take some Q&A.
Okay. Well, it looks like the first question that we have here is asking, how long has your tracker been deployed in the field? And actually, it's a two-part question. And how many megawatts have been deployed? You want to take that one, Isaac?
Sure. Well, so our first tracker was deployed, I believe, in around 2008. So I guess about 8 years in the field so far. We've deployed approximately 75 megawatts, and with the recent improvements that we've been making to the product, we'll be seeing that number double very soon. So we're excited about that.
Great. Next question here is asking, how does Sunlink approach viewing a complex ground mount site and determine what racking product would be most suitable for that particular site?
Well, that is a good question and a complex one as well, depending what the specific conditions are or what the challenge is. Most commonly, we'll see geotech questions about what type of foundation is appropriate for these conditions. So our PowerCare team is experienced in that, can do everything from testing to provide recommendations on the best solutions, whether you're hitting refusals or corrosive soils or anything else that comes up. Terrain following we've talked about quite a bit here, depending on the site and what the customer is trying to accomplish, meaning where is it and how much are they trying to install and at what price point we can offer a variety of solutions. So it's something that we're happy to do is look at the full range of possibilities and provide a recommendation. Whether that's on a single project or oftentimes a portfolio of sites that can vary quite a bit from location to location.
Okay, great. Looks like the next question that we have in here is asking if our tracker and the TECHTRACK and GEOPRO are available internationally.
So yes, we've deployed both fixed tilt and tracker systems internationally, notably like in South America and Southeast Asia. We have a very reliable international supply chain. And sometimes, or oftentimes, we are even able to provide some engineering support in dealing with local codes and things like that.
Excellent. We have another question here asking, when will your VERTEX product be available on the market?
Well, the VERTEX is available for download out of the App Store next month, and that's going to be the great first opportunity to take a look at its capabilities. We're porting into it some data from a project that we're doing O&M on, and can see what that project is doing in real time. I would encourage whoever asked that question to tune into the webinar next month to see more details about the release of specific features.
Excellent. Okay, well, we've actually run a little bit over on our time, so I want to thank everybody for attending today. And if we didn't get to your question through the Q&A chat, we'll certainly follow up individually with you via email. And appreciate your time today.